Hi, so earlier on we were down in the field where we collected the seawater sample. So we've brought this now back to our lab, and what we're going to be doing is we're going to be testing the pH of this sample using measureware, which is from Analog Devices, and also one of our ZP pH sensors. The thing about these sensors is they look nothing like traditional pH sensors. Traditional pH sensors, they're often glass or steel barrels, about 10 millimeters in width, at least 20 millimeters long. They drift, you need to add solution to them. They're not necessarily very robust, and they definitely drift with time. Now, so what we're going to be doing is we've taken one of these pH sensors and we've plugged it into the measureware board. So this is available for Analog Devices. There's a little pH sensor in there. The first thing I'm going to do in this experiment is I'm actually going to take a known pH. So I'm taking a known pH of pH 9. I'm adding 10 microliters at a time. So that's 1 and 2. That's enough. So that's about 20 microliters worth of buffer. So what we'll do is we'll hit measure, and what it's doing now is it's basically measuring the voltage due to that pH. So it's just going to come to plateau in a bit, and when it's done that, then we'll be able to do the seawater measurement. So we'll give it a few, we're at 25-30 seconds. And it's starting to, as you can see now, it's starting to sort of plateau. And we'll give it to about a minute. And now what I'm going to start doing is start thinking about adding on the seawater sample. So all I'm going to really do is I'm going to remove the known pH and then add a little drop of the seawater, and we'll see what we get. So if you want to watch how I do this, so what I'll do is I'm just going to take some, I'm just going to wick this off and add in a drop of the seawater. So then if you zoom in on that, you can see that we've changed the voltage, and the reason the voltage is changed is because of the pH. So as long as we do a calibration of our sensor, or we know the calibration factors, we can turn that voltage back into a pH. So let me summarize what we did. So the whole subject of what we're working on is making low-cost, robust, micro solid-state sensors. In this first example, we're showing the combination between measureware, which is a really nice platform for rapid prototyping or product development, because it integrates beautifully with these pH sensors from Zimmer and Peacock. And so what we did is we put on a known pH, and measureware recorded the voltage due to that, and that's kind of like a 1-point calibration. And then we put on the seawater, and we got that change in voltage, which was due to the pH. And so that allows us then to quickly calculate the pH of the seawater. And our intention then is sensors like this are low enough cost and robust enough that rather having one sensor in one body of water in one place in the world, you can have many more sensors distributed either in the same body of water or distributed globally. So if you have any questions regarding the integration of measureware and sensors, including pH sensors from Zimmer and Peacock, please don't hesitate to contact us. Thank you very much.